This is a continuation of Hi all. This is a continuation of the Packet Tracer Lab that was posted on the Facebook page, Facebook group actually. Let me try and get the name of the group. Now, in the first video, I started working on the lab, and I was able to get to certain part before I had to take a break, and I intend to finish it up. But again, the group, the Facebook group is called Cisco CCNA Study Group. It it is to me a sister group of the. Let me see if I can get this for you. Typically, don't like to show my mail. Google Plus. That's what I actually need. So the it's a sister group sort of for to the CCNA Hangout Study Group. Why I say that is because most of the members in the CCNA Hangout Study Group are actually members of the Cisco CCNA Study Group. That's what I found out. Most of the active members, I see them in both groups. Now, usually Hangout, in the Hangout group, or I call it Hangout group, but it's actually the community group, CCNA Hangout Study Group. We use that for mainly hangouts and recording videos or tutorial events. You'll see a lot of hangout listings. We rarely send each other, we rarely post questions here, like question of the day, stuff like that for people to handle or to try and resolve. And we do that mainly on the Facebook channel or Facebook group. Here we type different sorts of questions that people answer, um, and it's interactive. You know that as at that time, someone usually is going to be on Facebook anyway, and they would respond to it. Actually, there's a new response. Um, okay, so not join face. I'll handle this later. Um, but yeah, things like this, typical questions, or submitting stuff like that, different approaches to things. So we always place that there. Sometimes questions asked though are not limited to CCNA, so just be aware about that. And there are a lot of CCNP members here, so just be aware that the person you're talking to or who may be responding to you most likely is not CCNA, or maybe he's about to get CCNA, has got a CCNA or his CCNP. But it's just a collection of people. We share ideas. There's never, it's never too late to learn anything, and you can never know everything. All right, so I got the lab, and the reason why I'm showing this is because I like to give a shout out to the guy who posted the lab. He actually wanted help with the lab, and I decided to just take it up. So it's CPG, I believe that's his name. Yeah, so there's the lab itself. So I decided just take the lab on, and we'll do a video on it. All right, let's go to it right now. Okay, so here's the lab. Now, so far in the first video, I configured route 0, route 1, switch 0, which is one on top here. I changed the IP addresses of the, I believe the PCs, PC2, PC3. I did that. I configured the interfaces on both on the two interfaces on the routers as trunk links using sub interfaces. I configured um, the interface, adjoining interface to the routers from switch 0 as trunk, and the um, interface or ports connected to the PCs as access, switch mode access. I I can quickly go through the configs. Let's look at that of router 0. I try to make it big so that it will be easy for people to see, but I think I made it too big. Well, anyway, leave your comments below. Let me know if everything is so big. I'm just trying to make this available for the those who want to maybe go through this lab and want to like have a clue about how to go about the lab or approach it and why some things should be done in a certain way. So I'm going to do show run here. Now this, as you can see, is for the router 0. I do have um, I do not have the service password encryption set yet, so all my passwords are available or can be visible. The host name I changed to router 0 for sanity, so that when I'm working on the console, I'm actually aware of what um, device I'm working on. Next, you can see I do have gigabit 00. Now the VLAN for gigabit 00 is VLAN 1, and I've configured an IP address for it, 20.20.21 a /24 subnet. I did this on purpose because I needed that to let OSPF work. For OSPF to work, both routers need to be able to communicate. And to ensure they do that, I need to ensure that they both have a common VLAN and common IP address space or subnet, whereby they can form adjacency. Okay, and next I configured the sub interface for VLAN 20. If you noticed, router 0, which is the router on my left, I hope it's on my left according to the screen, but it's on my left. Oh, I've been talking without sharing not the screen. Oh boy, I'm gonna have to do this again. Okay, all right, so this is a goof. I'm restarting. Hi everyone, this is my Wakubayo. I'm a member of um, both the Facebook Cisco CCNA study group on Facebook and a member of the let me get it, the CCNA Hangout study group. I'm also a member of Router Gods and other groups like that. Now I'm trying to work on I'm continuing my work on a lab that was posted by CP Gabriel. Shout out to him. He wanted some work done on it, an explanation. I couldn't really contact him because he posted it some time ago. But I just thought it was interesting. Let me work on it and see uh, the different approaches I can take to results in the lab. It's a simple lab, really, but it's good for a review. So this is the lab. Now, in the first video, I actually configured everything. Not everything. I configured most of the stuff, like the routers and the first switch, upstream switch. I started work on the bottom switches, but I didn't configure each channel. I left that out. All right. And I intend to get that done today, or in this video anyway. Now I can quickly go through this. This is show run. I think I did show run. You know what? Let me do it again. Show run for router 0. Now you would notice, if I can make this smaller, this is for this router. You can see on the side here on the left. You'll notice I didn't configure password encryption. So any password I put in here is going to be available or visible. Next, we have the gigabit interface. Now take note, the gigabit interface 00 is configured. It's in VLAN 1. That's the um, That's the native VLAN. Native VLAN 1 is default. So this is a VLAN 1 2020.20.1. Like I described in the first video, I had to do this to ensure that OSPF works. And by doing so, I ensured that VLAN 1 is available on both route 0 and route 1, and they both share the same subnet address, and with that they can actually send hello packets, which are actually multicast packets, within that same subnet and form an adjacency. Okay, now and once they form the adjacency, they can advertise their routes or available networks or subnets that each have, and can populate their routing table. Um, Now, I, however, configured all the links on both routers as trunk links. I used the subinterface command to do that. As you can see, um, subinterface G0020. Remember, the 20 is not what turns on encapsulation or VLAN encapsulation. It is actually this command, encapsulation.iq. They specify the VLAN 20. Alright, and that's how you create a VLAN on a router using sub interfaces. And I can configure an IP address. Now, if you look at it, the router 0 has VLAN 20, VLAN 40, and if I move this away so you can see it, we do have VLAN 20 to be 172.16.0.0. That's why I have this subnet mask 255.255.0.0. Okay, and if we scroll down further, I did the same thing for gigabit interface. So I'm just showing you this just so that you can um, follow through uh, the configuration I did so far and have an understanding of it. So that's basically what I did. For OSPF, I cheated. I cheated really. I used the network command that simply says advertise all interfaces on this router, advertise OSPF on them, and the area is 0. All right, and that's it. I did something similar, almost similar stuff on the other router. The only difference will be the VLAN that's changed. Here is 1030. On route 0 is 2040. Now on the switch though, on switch 0, okay, I put in the password here. Now if I show run, you will notice that yes, I do have service password encryption enabled. I did type in the enable secret, give it a password. Password actually is Cisco, but because I have the password encryption on, it hashes it like this. Right now, this in itself is not uh, password encryption doesn't really make it secure. What really makes it secure is the enable secret. This is more secure. So just have that in mind. I had, because I was going to use SSH, I for local login using the V2I lines, I had to type in the IP domain name. I made it myoa.local to be consistent. Next, I configured the username, switch 0, and the password. Of course, password is Cisco. Like I said, it was secret that actually made it more, robust. Made this password hash and crypto more robust. If I had just used service password encryption, you see the Cisco password. Look at this is how something similar is going to look like this. May not be exactly the same thing, but something similar. So you can see this is not as secure as this. Who would believe this is Cisco? And you can believe this is Cisco more easily. You understand? Now let's go on. I do have um, the interfaces configured. Hmm, strange. I forgot I actually started work on this. I'm going to make changes to it. In fact, let me do that now because I would like to make it like fresh install. I'm going to remove. I'm going to remove all this configuration I did here. Um, oh wait, hold on, my bad. Sorry. This is actually correct configuration. I forgot the switch I was on. This is switch 0. That's the switch on top. I actually forgot. For a moment, I thought I was on switch 1. Sorry. So my bad. So it's switch 0, one on top. Um, and if you can look at it, fastnet 01. Fastnet 01 is connected to PC2. That's why it's configured as switch port mode access. And the switch port VLAN access VLAN is 30. Um, In addition to that, we were told to configure port security. Now, the default way to go about configuring port security is to do the configuration first, then enable it. This is the configuration, like put in the values you want first. After that, now put in the switch port. Now enable switch port security. Now, this is something you should know. I configured it to because it was required that for PC2 or for fast internet 01 on switch 0, we should have switch port security sticky mode. Now I turned on sticky mode. I didn't configure this MAC address there, but it learned this MAC address from the frame sent from the PC. Once I gave the PC an IP address to frame, it sent something. It sent a DHCP to find out the MAC address of the default router, which I configured. Let me show you that for PC2 IP configuration. See, I configured the default router and DNS as 10.10.10.10.1. So by default, the PC would send an APP request to find out what the MAC address is and populate its MAC address table. And that is how the switch 0 learned the MAC address of the PC. So once you have sticky and you see this, it actually shows. Now, I think I reloaded this switch. I'm not sure if I did. I will test this out maybe in the next video to see if I reload it, if the MAC address disappears after I reload. I don't think it would, but we'll just check that out. Now, in addition to that, on fastnet 02, which is connected to PC3, we have the same port security violation restrict. In the first video, I described what restrict is. I'm not going to go over that again. But if you notice that this was manually added, check the first video. I showed how I got by getting this MAC address. Next, I configured ports fastnet 03 and fastnet 04 both as trunk ports, right? And I configured them to be dynamic desirable. Now, in the first video, I did comment that packet tracer seems not to work properly by most times anytime I type switch port mode dynamic desirable, it doesn't take effect. I found out later, and that's because I noticed in the configs that you actually need to configure the switch port trunk allowed first. So it's a I think it's an operandi. It's a mode operandi or a way of doing things with Cisco. Before you enable the feature, you should type in the requirements so that once you turn it on, it actually works that way. All right, now let's go next. Let's go on next. What's important here is we do know that we're using dynamic desirable, and dynamic desirable is going to auto negotiate, and that's about it, I believe. Well, not totally. This VLAN one is just misconfiguration. I'm going to remove it. I can't use the same VLAN one, yes, but not this address space 2022. I will need to give it a different IP address space so that it can connect to the. I'll have to configure a different IP address space on the routers too. I intend to do that for VRRP. I intend to build this lab up. Also add more features other than what we have here, so that I have VRRP going on, and um, it can move or it can switch from one to the other. Just just to make that available. And I configured the VTY lines. I configured SSH transport mode. I'm shocked I didn't see crypto. I'm not sure I really finished that. Okay, I didn't finish it because though I configured SSH for the VTY lines, I didn't configure crypto. I'll quickly do that now. So config T, that'll be crypto key generate RSA. Well, packet tracer doesn't allow you to type the whole thing out, as you can do it in GNS3. So says you already have RSA key defined for that. Okay, so I already have a key. All right, let me replace it. Okay, I'm gonna 1024. So show run, do show run. I forgot there's a way to actually show what keys you have available on it, but I'll go into that later. So I do have that configured. Let's go ahead and move on to what I really need to do now. So we're on base here. We've configured routers 0, router 1, switch 0. Switch 1 is where we really need to continue our work on. Now the idea is this: fast Ethernet 0, 1, and 0, 2 should both be trunk ports. I'm going to configure an Ether channel on fast Ethernet 0, 3 to 0, 4, and 0, 5 and 0, 6. So those two combinations are going to be Ether channels. Simply, the reason behind Ether channel is just a way to maximize ports, to ensure and to aggregate ports together to have a larger bandwidth to work with. So if you have like fast internet, we only have 100 megabytes per second to work with. But if you want to get up to maybe 200, 300, 400, you might want to go and buy a fiber cable. But what if you can't do that? What if you're stuck with the switch you already have? Well, the way to go about it is to use its channel. Each channel will combine ports together. I think a maximum of 8 ports together, and make them logically look like one port. So if I have 8 ports together, I can get up to about what, 800 megabytes per second, right? And it would do many things, like when you're sending traffic across the Ether channel, it will load balance the traffic across. Depending on, you can actually change it if you want it, but it will most likely load balance the traffic going across the Ether channel, or the range of ports assigned to an Ether channel. It's going to load balance that traffic across all those ports. So it's a very good way to um, manage traffic, and to optimize the use of your device. And it's primarily, I believe, used in um, either the distribution layer or the core. All right, now, because that's where you see most of the traffic actually is going to be in the core. All right, now let's go ahead. Let's start. Let me just know where I am. Now I did configure password on this. It's still Cisco. Do show run. Let's see what we have here. So yeah, you can see service encryption. Same, it's similar. Not same thing exactly. I do not have any of the interfaces configured. Right, cool, which is fine. So what I'm going to do now is go to config T. I intend to configure F01 and F02 as trunk ports. Now I'm going to go and do that right now, and that is interface F01. Okay, and I'm going to make that a trunk by saying switch port trunk. allow VLAN. What VLAN should I allow here? Well, I need to allow one. I need to allow, I think it's 20. Yes, I believe it's 20. No, is it 20? Let's double check. All right, on the router says 20 because it's F01 on this switch 1 is actually connected to router 0. Router 0 only deals with with 40 and 20. I know 40 is upstream, so 20 is downstream. So 1 and 20. Okay, then I will type in switch port desirable. Oh, no, sorry, my bad. Switch port mode dynamic desirable, and that's how I make it a trunk. To confirm that it's a trunk, I do show interface trunk. Oh, still not listed. Okay, then that's maybe this is a real problem from um maybe this is actually a problem from wait, hold on, let me fast forward this. Okay, it's turned back to green. Maybe that's why. Still not showing. I suspect do show VLANs also would list Fastnet 1 as in VLAN 1, which is what it shouldn't do that. Okay, let me spread this out a bit more so we see. So it's this is actually this is a confirmation of it. This is actually packet tracer issue. The only way to add this to trunk port, I think for this version is broken, and the version is 6.2. As you can see at the top over here is version 6.2. It's broken for some reason. If you know anyone who writes the packet tracer code, you can talk to them and tell them that it's broken and they should fix it. So the way to go to get around that is to actually say switch port mode um, trunk first. So this actually makes a trunk port on packet tracer, and then you can now switch back to switch port mode dynamic desirable. It's sad that that's what happened, but yes, let me do this show. Let's just confirm it now. Do show interface trunk. All right, now you can see that we have the trunk configured for fast select 1 and have VLANs 1 to 20 there. So that's really what I need. In addition, if we do show VLANs or show VLAN, or do show VLAN actually, show VLAN. If it's noticed, Fastnet 1 is no longer listed because it's not a trunk port. All right, now I'm going to work on Fast Ethernet 02. That is, you can see that Fastnet 02 for switch 1. This is switch 1 I'm configuring, and I want to make Fastnet 02 is connected to router 1. So we're going to make that a trunk port by saying switch port. What am I saying? Switch port mode. Yeah, remember, it doesn't work if I just do desirable. I have to do trunk, then switch port trunk. Allowed VLANs. Oops. Allowed VLANs. What VLANs do I need here? 1 and 1. 1 and 10, I believe. 1 and 10, because 10 is the VLAN on router 2. Okay. And actually, that's the sub interface I configured there. So it's 1 and 10. So I'm going to go ahead and just say enter. And then I'll change this back to desirable mode, dynamic desirable. And with that, if I do show VLAN, you'll notice that, let me scroll up a bit. You'll notice that 1 and 2 are no longer listed here. That's proof. In addition, if I do show interface trunk, or do show interface trunk, you'll notice that Fastnet 1 and 2 are both trunks, and their mode is desirable, dynamic desirable, actually, not just desirable, but dynamic desirable. Both of them have a native VLAN of they have as their native VLAN 1, right? And you can see here status trunking. Right, and I think that should be all. It says concerned about this though. It says what? It says VLANs on spanning tree forwarding state not pruned. F1, F01, F02 none. I'll check that out later. Spanning tree, no, Packet Tracer has a weird way of implementing stuff. It's not the real iOS, so it's just a simulation. So you do get the odd behavior on Packet Tracer. All right, now what I need to do now is to configure a trunk port, not a trunk port actually. I need to configure the Ether channel for both sides on switch 1. Now, to do that, I'm going to use the command called interface range. Now, I'm going to configure interface range for fast Ethernet F03 and F04. I'm going to combine them together to form an Ether channel that I'll name as mode 1, or I'll name as group 1. And I'm going to make fast Ethernet F05, F06 as group 2. You know what? Let me type it here. Switch 1, F03 to 4 should be channel group 1, and can I make it bigger here? Group 1, switch. I'll just copy this. Copy, paste. All right, so 5 and 6 should be group 2. Um, switch. What number is that? Switch 2. Fast Ethernet 1 and 2 should be group 1 because they should match. Fast Ethernet switch 2, fast Ethernet 3 and 4 actually should be group 3. So you can see for switch 2, I must make sure that the group numbers for my port channels actually match. That's important. Also for switch, I've done switch 2 twice, I believe. So switch 1, I've done that twice, switch 2 twice, switch 3 is the next one. Switch 3, fast Ethernet 1 and 2 should be channel group 2. And 3 and 4 should be channel group 3. And I think I'm okay with this. So let me move this over here, and I'm going to draw a diagram here, I think. Okay, and I'm good. All right, cool. So that's the information there, so that we don't get it mixed up. Now let me go back. I'm going to close this route to 0. Just go straight to switch 1. Okay, and I'm going to configure with that. So the fast Ethernet or the interface range is what I'm going to use. Let me make this, bring this up. Interface range. So you know what? Let me exit out so you can actually see the full config. Interface range. It should be fast Ethernet. Take note, the options you have available. I'm gonna do this next. The next configuration, I'll make it fast. I'm just doing this so you can actually see what what you actually have available to you. Zero, right? Switch a number is three, right? Hyphen and four. And I'm gonna put that in there. Now, I usually do this when I'm configuring into channel. I usually shut it down first. So I'm gonna shut down the port. Or no, I won't shut it down. I would. No, let me just shut it down. Shut. So I've shut down those two range of ports. While I'm still working on that range, I'm gonna configure the channel group. See channel group. As I said, channel group should be what, one for 3 and 4 on switch 1. Okay, and the mode should be, you know what, for the mode we have two types of mode. We have LACP, which is what is used by all non-Cisco switches, and we have PAGP, which is used by Cisco switches, Cisco proprietary. So what I'm going to do here is I'm going to just stick with the LACP. Let's use LACP throughout this lab. Let's just use it. Or you know what? Let's use PAGP. It doesn't matter. We just use any one of them. I'm going to use that. Let's use PAGP. So PAGP, to be active, I'm going to try using. I'm going to keep them all as desirable. Okay. So that they actively seek to connect to each other. And that's what I'm going to do there. So desirable. What else do I need? And that's it. Now that creates the port channel. If I do show run, no, I actually don't need to do show run. I actually just need to do show IP interface brief, and you will notice that I have the port channel 1, which is configured, but it's down currently because the ports are actually down. Now I want to make, the good thing about the Ether channel is like you can actually now configure all you want to configure in terms of like trunking on that Ether channel, because take note, it sees the two ports as one channel now. Okay, so I can configure that interface P1. That takes me to the port channel 1, and I can now configure that as a trunk port. Switch mode trunk, switch trunk, allow VLAN. Now, what I'm going to do here is I'm actually going to configure VLANs 1, 10, and 20, so that this way, if I have VLANs 1, 10, and 20 between switch 1, 2, and switch 3, it would mean that in the event that the link between switch 2 and 3 fails, PC0 can still use the link between switch 2 and 1, right? In the event that so it just provides redundancy, which is part of the reason why I actually have this kind of configuration, where the three switches are actually connected together. Is all it means to prevent what we call it. There's a technical word for it. I can't remember the technical word, but what it really means is that where you have only one route to a particular device or information you need. So having only one route is not a good thing, really. In case that route breaks or has a problem, you lose access to that resource. So typically, the idea is to configure it as Ether channel to increase the number of bandwidth, and in case one port goes down, you still have other ports to work with, and also to have like triangle kind of network arrangement, so that in the event that a switch port or some switch ports have problems, you can always switch around using the other ports on the opposite switch. And STP, by the way, is able to help us out to implement this by removing all loops. VLAN loops, it just removes all that. So that's what spanning tree does, and the spanning tree allows us to include redundancy in what we do. All right, now let's go ahead and see what else we have here. So the command is switch port trunk allowed VLAN 1, 10, 20. Sorry if I'm sounding tired. It's actually 3 a.m. in the morning. I'm a little exhausted. I'm studying all the stuff. Okay. Oh no, I didn't do that right. Oh goodness. Let's go ahead and do it again. Switch port trunk allow VLAN 120, no 110 and 20. So it says that it's compatible because both ports, both members of that port channel actually share the same configuration. So that's why once I make them a port channel, I do all my configurations on that port channel itself. I don't do it on the interfaces anymore. Just in case there's a change, it will knock that. Once that's the thing about ether channels. The configuration on all the ports or members of that ether channel must be the same. Otherwise, that the one that doesn't match the rest is kicked off the ether channel group. All right, so the Scylla group, let's configure switch port um, mode. Um, Let me just make sure I have this trunk. The switch port mode, dynamic, desirable. Okay, and I've made the port channel a trunk port. Now let me go again to, so I'm going to go to interface range. Um, the range for what is it? For switch 1, I intend to make the switch ports F05 F05 and F06 a channel group 2. So making it each channel 2. So that's interface range. Interface range F should be 056. All right. Now once I have that, I'm going to make a channel group. So channel group. I'm going to give it a number. What number did I say? 2, right? Channel group 2. Mode. What mode did I say I will use? I was going to use all throughout. PAGP. So I'm going to use desirable PAGP. Okay. And that's that. And then I go to, if I do show IP interface brief, we can notice that we have the second port channel listed. So I'm going to go to second port channel P2, and what I'm going to do is I'm going to make that port channel a trunk port by saying switch trunk allow VLANs 1, 10, 20, and I'm going to, what did it say? Okay, it's compatible. I'm always very careful. I always check the messages just in case something's wrong. So it says interface port channel to change to state up, line protocol on interface port channel to state went up. So it's up. Oh, I forgot. Like I said, I usually shut down the I usually shut down the interface. Okay, it doesn't matter. I'll still get this done. Let me make it a trunk now. Interface P2. I'm gonna make switch port mode. I did trunk allowed. I'm going to switch port mode trunk, and then I'm going to configure switch port mode dynamic desirable. All right, and then I'm going to tell it to, I'm going to go to interface range. I like using shortcuts a lot, so just in case, just bear with me in case you do see shortcuts. Oh, what did I type wrong here? Oh, sorry, my bad. It should be. Oh, okay. I'm actually in the P0. That's why it didn't work. That's funny though. I expect it to work. Interface range, fast internet 0, 5 to 6. I'm going to tell it to shut there. Cool. So with this, I've configured switch 1 as a Ether channel, and I configured the Ether channels for Ether channel 1 and Ether channel 2 as um, trunks, right? So I configured DTP on the Ether channel. The Ether channel mode I'm using is PAGP. It's very important to remember it. Sometimes I call it PGAP. I don't know. I'm always thinking about, maybe I like golf, so I think about the PG tour, and it mixes me up a lot. So it's PAGP, and yeah, that's that. Now the next thing I need to do is to go to um, switch to. Okay, I'm gonna go to switch to and just work on this. Now for switch 2, the ports in questions are Fastnet 1 and 2, and Fastnet 3 and 4. So enable. I put the password there. So config T, interface range, um, interface range 1 and 2, I believe. F01, 2. I'm trying to be careful. Channel group. Um, the channel group for switch 2, for fast internet 1 and 2, that's facing switch 1, fast internet 3 and 4. So fast internet 3 and 4 on switch 1 is group 1. So I'm going to make it channel group 1, and the mode should be desirable. Let me just show you guys that. Desirable is what I'm using because it is PAGP mode. So that's what I'm using. That's what I'm typing, desirable. Um, I type enter and it creates a port channel. I instantly go to port channel 1. Oh, come on. Interface T1, and then I configure the trunk over there too. Oh, I forgot to do that. I've actually forgot to shut down interface range. First of all, I have to exit this because it didn't work last time I did that. Interface range. Um, F0. Oh, come on. 0, 1, and 2. And say shut. I usually shut it down. That's just me. I had to shut it down first. Then interface P 1. Okay, and what do I have to do? I have to configure the trunk ports now. So switch ports, trunk allow, VLANs 1, 10, 20 compatible. So I have no problems in configuration. Switch port, mode, trunk, and then switch port, mode desirable. dynamic desirable. Okay, and I think I'm done with that part. Next, I'm going to go for interface range. Wait, hold on. I'm going to exit out of this port channel. Next, I'm going to go for interface range. F0, 3, and 4. That's for port channel 3. If you look at that, 2F034 is for port channel 3. I'm going to shut it down first. Then I'm going to do the channel group command. You know what? Let me see if I can get that channel group command by just going up. Uh, I am surprised that it doesn't have that much history. Anyway, channel group 3 mode desirable. Okay, and I go to interface. Let me just make sure. Do show IP interface brief. Come on, that's P3 channel group 3 interface P3. That is from channel group 3, and next I configure the ether channel group 3 as a trunk. So here we go. That'll be switch port, trunk, allow, VLAN 1, 10, 20. It's compatible. Go switch port, mode, trunk first, switch port, mode, desirable, mode, sorry, dynamic, desirable. All right, now by doing this, if I do show VLAN, you would notice that oh, this is strange. Well, it still lists fastnet 1 and 0, fastnet 1 and 2, 3, 4. It still lists them all. If you remember, I didn't configure the port. I didn't configure the trunk on the fast Ethernet ports. I configured it on the Ether channel ports. Okay, I was expecting that it would list. It shouldn't list Ether channel at this point. So let's see if we actually have the trunks showing. Show or do show. Um, I don't be surprised if we do get strange results. This is packet tracer we're talking about here. Show interface trunk. Imagine reading. As I said. Goodness. Oh goodness. All right. Um, packet tracer just sometimes just does crazy stuff. Anyway, let me do show IP interface brief. We have the two port channels configured here, and I'm going to just do show ether channel. We have the right ports configured. Maximum ports is 1, 2, PAGP, PAGP, which is cool. And I have my ether channel ports configured right. Now I'll do show run. Let's see what happens. Okay, you guys notice something? I did not configure on switch 2. I didn't configure this on the interface. I configured it on the port channel, but it's showing on the interface. You can see that, right? It's showing on the interface. This is where I configured it, but it replicated along its members, and that's right. That's the way it should work. I'm just surprised that even with this configuration, that we do not have um, trunk ports showing up, and that's just disappointing. If it's the actual code on an actual switch, it would not you won't have this problem. But this is packet tracer. It's a simulation, so sometimes it just gives you weird results. Period. I'll leave this as is and continue. I'll continue with the other configuration on what switches it. What switches next? Switch 3. So I'm going to work on switch 3 right now and just do something similar. So just let me finish it. I'm not going to talk. And just finish this configuration. Config T, interface range. Um, okay, so this is wrong here. This should be switch 3. Fast Ethernet 1 and 0. 1 and 2, sorry. Should be channel group. What channel group should it be? 1, it should be 2. Mode desirable. Interface P2. Support trunk. Allow VLANs 1, 10, 20, and switch port mode trunk. Let me do show interface trunk. So doesn't what is logical. So let's go ahead. Oh, I forgot to shut down the port. It doesn't matter at this point because I shut down the other two, so it doesn't really affect it at this point. So switch port mode. I'm gonna change it to desirable. Dynamic desirable, right? And I go to next interface. Exit out of this first interface range. Fast Ethernet 3. Right. Let's go to no short. Okay, and going to I'm going to do short, self no short. Short first. Next, I want to do channel group. What should be 3 and 4? Channel group 3. Mode desirable, and I say interface P3, and I configure that as a trunk, so that switch port trunk allow VLANs 1, 10, 20. Switch port mode trunk, switch port mode dynamic desirable. Okay, I've configured that, and all right, so I've configured all the switches. I need to just double check something. Do show run because the switches 3 and switch 2 actually have PCs connected to them, and I need to configure that. I'm not sure if I did. Yeah, I did. Faster than 5, I actually did earlier before the second video. So faster than 5 goes to PC2 on VLAN 20. That was configured correctly. And for switch 2, do show run. Faster 5, VLAN 10. Yeah, it was correctly configured. Let me double check switch 3 for, yeah, I didn't configure the security part of it though. All right, I'll do that right now. Configure interface F05. Let me configure the switch port security part of it. So the violation is what? You know what? I'll have to take this up a bit just so I can see it. So the violation is restrict. Oops. We'll reduce this a bit. Press enter. So violation is restrict. What else? Switch port security. Maximum is what? 1. Right. Now, are we using sticky on this one too? I think we're using sticky on all the PCs except all the ports connected to PCs except the one connected to PC3. So I'm going to get you sticky also. Thank you. I just reduces the work I'm doing. Switch port MAC address. Sticky. Enter. Now I enable switch port security. All right, cool. I have that done. Do show run. All right, so that should show it done properly. So we have sticky, we have port security, we have access, we have all that. Now that's fine. Now that I have this configured, I can now enable my ports. So I'm gonna do something interesting. Exit. I'm gonna go interface range. F0. This is on switch 3, right? F01 to 4, and say first of all, let's just say short, and then I'm going to say no short. So I'm going to turn everything on. So that's why I shut it down. Then I can bring it back up. And I'm going to go to switch 2. I'm going to do the same thing. Well, exit, exit, interface range, F01 to 4, right? And I'm going to go shut and say no shut. That brings everything back up. And I'm going to go to switch 1 and enable Cisco config T interface range. Now I'm not going to start from 1 and 2 because 1 and 2 is not an easy channel. I'm really concerned more about 3 to 6. So that'll be fast internet 0, 3 to 6, 5 or 6. And I'm going to do shut and then no shut. So this should bring it all up, and this is how you configure your Ether channel, basically. All right, I'm going to fast forward this just to let SCP have its say. Cool. So if you can see, if you notice, I believe if you notice, one of these two switches, or both switches here, have no ports blocked, right? All right. Now, one of the switches here, I do notice that it seems one side of it is blocked. So most likely switch 2 or switch 1 actually have, one of them is going to be the bridge. It's going to be, sorry, what do they call it? Root bridge in spanning 3. Yeah, definitely. I'm leaning more to switch 2 being the bridge. The real reason is because it appears that the block ports are actually on the ports facing switch 1. And if switch 1 is the root bridge, then I do not see why they should be blocked. But if 2 is the root bridge, then I can understand why the port between switch 3 and switch 1 actually is blocked. All right, cool. So let's see if the trunk exit. Let's see if the trunk took let's see if it took. This is switch one. Do show, no, yeah, do show. You know what? Let me just end this completely and then show interface trunk. I do. Oh, okay, it worked. All right, cool. If you notice, oh my goodness, I'm sighing again, guys. I'm sorry. I'm just fed up with packet tracer at this point. On GNS3 and on actual switches, you shouldn't see this FA01 and FA02. The switch should see it as one port, right? That's what should happen. You should actually see P01 and P02. That's all you should see as a trunk ports. And the reason why I say this is because I've done this on production um, switches, and that's what you should see. Packet tracer is a simulation, but well, at least we know that the trunks are working on switch one. We shouldn't have a problem with that. The allowed VLANs. Oh my goodness, I made a mistake. I'm sorry. Yes, this is actually correct. FA01 and FA02 are both configured trunks. Remember, I configured them separately. I keep mixing up the switch I'm working on. Switch one, this FA01 and FA02 are connected directly to the routers. So I manually configured them as trunk links or trunk ports on the interfaces F01 and F02. So that's why it's showing up here. But for the Ether channel, remember, that's for 3, 4, and this is 5, 6. They're both showing as trunk. So this shows Ether channel is working right. You can see that the VLANs 1, 10, and 20 is allowed here. For fast internet, I'm only allowing 1 and 10, and here 1 and 20. Okay, and we're good. All right. So switch one seems to be working fine. In fact, let's do show spanning tree. Uh, and as you can see, okay, now show spanning tree. This is for VLAN 1, by the way. In VLAN 1, what ports do we have? I need to make this bigger. Okay, in VLAN 1, okay, this is odd. Oh, I see a problem. Oh my goodness. I'm so sorry. I made a mistake. Um, this is my error. I forgot to create the VLANs. I actually thought I did. So VLAN 10, that creates VLAN 10, VLAN 20, that creates that. I should have done that for all the switches. Uh, VLAN 10, VLAN 20, okay, and uh, VLAN 10, VLAN 20. I didn't configure VLAN 1 because VLAN 1 is on by default. I hope this doesn't mess things up too much. Because remember, as I said, I usually shut it down, then bring it back up. This might have messed things up a little. Okay, I don't have any. I think I don't have any red ports anymore. I only have. Uh, okay, it seems to settle down. Yeah, it appears to have settled down. I'm not happy though because I do notice this is yellow and this is red. I'll check it out. The problem was me not configuring the VLANs first. That actually messes up your Ether channel, and I may have to actually save it and then reload it before it works right. So let's just go through each of them once again and double check. So enable Cisco show spanning tree. Now we have the spanning tree for VLAN 1. VLAN 1 is this. It's this, as I said, switch 1 is not the bridge. Okay, so we have that. Um, this is VLAN 1, right? So that's +1. So it actually, the default is 32768, but because it's VLAN 1, we add one more to make it 9 as the priority. The MAC address is this. I do see, you can see P01 and P02 on spanning tree. Usually on, this is what I was complaining about. Usually you shouldn't have this listed. It shouldn't show up as that. It ordinarily should just take it off and see the spanning tree should see port channels as one port. You shouldn't see it listed like that. 10 for 10 for VLAN 20, sorry. Why is VLAN 10 not here? Okay, for VLAN 10, it says that switch 1 is the root bridge, which is, you can see how it flips it. In VLAN 1, it is not the root bridge. Oh, okay. I had some stuff there. Let me do this config T um, line console 0 login synchronous, so that we don't get bothered by messages. And now if I do show spanning tree, right, as I was saying, VLAN 1, uh, this, we shouldn't actually see all this here, but at least we can see that for VLAN 1, ports 1 and 2 is forwarding. That this is okay because 1 and 2 is connected to the routers, but 4, 5, and wait, no, 5, 6, and 3, 4 are on listening state, block state, which is odd. It shouldn't block. I don't think it should block. Anyway, I'll double check that later. Like I said, it was me not creating the VLANs. I messed it up. And packet tracer being a simulation software, it doesn't even help. Let's go on, but the configurations I showed on how to configure each channel is still correct. And now the VLAN 10, for VLAN 10, it says that this is the root bridge. Now, if this is the root bridge, we shouldn't have any block ports, right? So why is it in learning state? So what this just means is that for some reason, maybe it just looped us, we had a loop problem. And don't worry, as I said, and this is all because I decided to, well, as you can know, as I said earlier, I decided not to configure the VLANs before doing all this, and that caused all this chaos. And I apologize. Uh, so that's why it's showing up as red. Something was wrong. Um, but I'm fine with that, so long as my ports actually show as trunk, show interface trunk. That's really what I need to do first. Make sure my trunk links show trunk links show PO1 and PO2. Then show what's the stuff for ether channel? Show ether channel. I think it's summary. So ether channel summary tells me that I do have two channel groups. They're both in use. P1 0 and P0 and P1 and P2, or P01 P02. Now the bad part of it is it shows up as, okay, P import channel. All right, cool. So that means both of them are actually working fine here for switch 1. Now the second one is SU, U in use. S means layer 2, which means we have no problem there. So switch 1 is fine. Let me go to switch 2. Let me do right first. Copy, run, start, and go back to switch 2, enable, Cisco, so show interface trunk, right? That's fine. Um, oh, it's not fine. We have a problem, Houston. Port channel 2 is not listed. Okay, that might cause a problem. I only have 3 listed, so that's not right. Show interface, show IP interface brief. I'm sure I configured, see, in configured port channel 1, when I say show interface trunk, port channel 1, oh, it's not even listing trunk links. I could have sworn I actually configured, used that same command earlier and it listed packet tracer. Uh, we hear you. You guys can see I just used this command, right? And I got all that information. Suddenly I use the same command and I can't get anything. Now it shows again. So well now it shows us P1 pin up and P2 out. Well, it's configured correctly. It's just packet tracer misbehaving. And I think maybe a loop developing over there. So yeah, it most likely is a loop issue, and that was just because the VLANs were not enabled immediately. So I'm just going to do right. I'm going to make a copy of this. Let's show run the configuration. Okay, so we have. Let me go back up here. We have this fastenet 1 and 2 is configured correctly. For switch 1 and for switch 2. Fastenet 1 and 2. Remember, it's port channel. I actually did a port channel, but it reflects over here. Regardless, that's port mode 1, which is correct, and we have port mode 3, which is correct. Mode is desirable. Mode is desirable. I think maybe part of the problem might be that they are both desirable, and none of them is auto. So both of them are actually trying to actively negotiate, which might cause a problem. Which might make it slower to converge, period. STP to converge. Uh, but it shouldn't be a problem. Anyway, I can see that they're both compatible. Um, I can see that 1 and 2 look exactly alike. 3 and 4 look also exactly alike. 5 is configured right. Port channel 1 configured correctly. Port channel 3 is also configured correctly. All right, so right again, and I'm good with that. So I'm going to go back to switch 3, enable Cisco. I'm going to write this, then I'm going to do show interface trunk. Oh, I forgot. It should just be show interface trunk. Okay, in this case, 2 and 3 actually get listed correctly. And then what else do I do? Let's say show VLANs. The ports that I configured are no longer listed, which is really what I need to show here. See, they're not listed. We're not using 6. We're using 1 to 5. And yeah, that's it. This shows that this is well configured. Show spanning tree. Look at this spanning tree 1. So for VLAN 1, this is how it should look. As you guys can see, this is what spanning tree should do. Packet tracer is messing everything up, but this is what spanning tree should do. In real life, this is what you see. You see PO2, PO3. So please don't worry when you see all this error behaving in packet tracer. Just remember, packet tracer is actually a simulation, so it messes up. If you really want to see how this works, get actual switches, configure them this way, and it will work fine. You will have absolutely no problem. Now, I do have a problem here though, because my switch, my port 5, okay, my port 5 should be on 20, I believe. Yes, it's 20, so it's listed correctly. So this switch works fine, but the other switches are going crazy. So I'm going to do right again, and then I'm going to reload it. Yeah, confirm. We'll do the same thing with this. Right, reload, confirm. We'll do the same thing with this. Right, reload. I'm hoping the reload will make it stabilize. But if it doesn't, the configuration still works regardless. And that's how you should do it. It's just packet tracer not behaving properly. That's it. that's that's about it. I can't I can't go further than that. All right, I'm now going to fast forward the time. Um, it looks to be a little better now. I'm not seeing that many red stuff like that I saw the last time. I actually see a lot of green and a single red. How that happens, I don't know. But let's check it out. Let's go to switch one first and see what does switch one have for us. Enable Cisco show interface trunk. No trunk. Okay, so our trunk ports are listed correctly for switch one. I'm disappointed though, because if I'm switch one, I'm very certain I'm very certain that I did configure Fastnet 01 and Fastnet 02 as trunk ports. However, I don't see them listed here. All right, do show run. No, show run. Oh, packet tracer. I'm certain I did, and here they are. Look at that. But packet tracer doesn't see it as that. It's sad. This just shows like it's just a proof that packet tracer is broken somewhat, which is why people always advise though that try and use as close to the iOS code as possible. Simulations are good to an extent. They don't really give you the real look and feel. All right, and let me try and sort that out. And I think the way to sort that out is interface range F01 to 2, I believe. Let me just double check. Yeah, FA01 and 2, and I'm going to do switch port mode trunk. Switch port mode desirable, dynamic, sorry, dynamic desirable. Okay, now I believe this should resolve that, right? Okay, and I say show interface trunk. Now we list them. Well, since that works, next I do show it's a channel summary. For my ETA channel, I have my P1 and P2. They're both correctly configured and they're working really fine. Now show spanning tree, which is the whole idea behind this channel. What does spanning tree see? Again, spanning tree is working very well on switch one this time around. I can see that PO2 is listed. Instead of listing the individual ports, you can see list only PO2 and PO1. Now, FA02 and FA01 were manually configured. They are not part of a data channel. And that's how spanning tree should work with each channel, right? It should mask it and make the ports look like one single logical port. Instead of blocking one of the ports, it just allows traffic to go through both ports at the same time one in the same direction. So because it just sees them as one, if I look at 10, um, you can see that also same thing, very clean. Um, and this is perfect. This is 20, by the way, and this is VLAN 10, very clean, absolutely no problem. So switch 1 is configured correctly and behaving right. Let's go to switch 2, enable Cisco show interface trunk. Okay, the trunks are actually listed correctly here now. P1 and P3 show it's a channel summary. Yeah, these channels are working perfectly and shows pattern tree. You can see this is working fine now. So, like I said, was packet tracer misbehaving, and the best way to resolve it was just to save the config because I knew the configuration was fine. Save the config and just reboot it. Reboot it so as that time is rebooted, everything should work as is. So this is fine, and this actually shows everything is working fine. See, Fastnet 5 is for VLAN 10. It's not listed on VLAN 20. It's not listed on VLAN 1, and we're fine. So this actually is the root bridge. That's why none of the ports are being blocked. Right, now let's go to switch 3, and that'll be the last one of it. Enable Cisco um, show interface trunk. Okay, list the appropriate trunk ports P02, P03, and let's do show each channel summary. As you can see, we have it as we have the channel listed correctly. They are both working well. They are both in the port channel and they are in use. SU, right, and P using PAGP. Now the real taste of the pudding is in show spanning tree. Okay, and here we go. In fact, let me make it as big as possible. Show spanning 3. You see what I was talking about? Yes. You shouldn't. Spanning tree should see it as data channels, not as individual ports, and that is working well here. You can see what for port 2 we are forwarding, but for port 3 it's an alternate, and we're blocking on it. That's 1 port 3, but actually channel group 3, and that is for VLAN 1. For VLAN 10 is a little different. Oh, it's the same thing. So 3 is being blocked. 3 is being blocked also here. 2 is forwarding. Okay, and that's how it should be. This is how the lab should be. So 3 should be blocked here in this direction. 2, if this 2 is the root bridge, we shouldn't have any block ports. Okay, let me just double check because I saw. Right, cool. So VLAN 1, no block, no block, no block. So this visual stuff you're seeing here is see, because I do see red. It's just packet tracer misbehaving because I thought it blocked right there because I saw a red, but when I click on it, it's telling me it's not blocking. So I'll just believe what it did here, and if I go to switch one. Oh, you know what? Make it as big as possible. Switch one. Um, switch one is not the root bridge in any of the VLANs. So we should have forwarding. So we have root ports. See that? Root ports. So excuse me. I'm wondering why it's showing as designated for this though. I expected it should show up as root, not designated. Well, it's packet tracer. That it works this way is a good thing. All right. So I'm sorry if the lab looked it got boring after a while. When it comes really to configuration, it actually becomes mundane. What really is fun is troubleshooting, and that is what I hope we'll be able to do in the next video. Um, I will likely have a hangout and invite people just to let's configure the lab, and I do it, and we will. I'll try break stuff or just ask questions in regards to how do you show me it's so and the so. If you see this and that, what what is the problem? You know, stuff like that. So I'll be breaking stuff off the screen, and then people would try and tell me what to do to find what the problem is and how to correct it. So that's where the fun really is. All right, it's I think it's an hour video. Thank you for watching how I did this, and I hope you enjoy the lab session and you find it useful to you. Thank you very much. Have a great day.